titled Diabetic Retinopathy Detection Using ResNet 101 and DenseNet 121. So now coming to the introduction part, with the increasing prevalence of diabetes globally, the early detection and management of diabetic retinopathy have become paramount to prevent vision loss and improve patient outcomes. The proposed deep learning-based approach holds great promise in enhancing the efficiency and accuracy of diabetic retinopathy screening, thereby offering a valuable tool for healthcare professionals in their efforts to combat this sight-threatening complication of diabetes. By combining the power of ResNet 101 and DenseNet 121, this detection method represents a significant step towards proactive and accessible diabetic retinopathy assessment, potentially transforming the landscape of diabetic eye care and safeguarding the vision of millions of patients worldwide. Fine-tuning these pre-trained models on a carefully curated dataset of retinal images allows the system to specialize in diabetic retinopathy detection, optimizing performance and minimizing the risk of misclassification. So our main objective for this project is to offer a reliable automated tool that can assist healthcare professionals, especially in resource-constrained settings, to screen diabetic patients for retinopathy with high accuracy and efficiency. By enabling early diagnosis and intervention, this deep learning-based approach seeks to improve patient outcomes, preserve vision, and alleviate the burden of diabetic retinopathy on individuals and healthcare systems worldwide. As a result, it holds the potential to make significant impact in diabetic eye care, contributing to better management of the disease and enhancing the overall quality of life for diabetic patients. Fine-tuning these models on a carefully curated dataset of retinal images ensures that neural networks specialize in diabetic retinopathy detection, increasing accuracy and reduce false positives and negatives. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, first upload diabetic retinopathy dataset. The first step in the process is to obtain a dataset of retinal images related to diabetic retinopathy. This dataset should include a diverse range of retinal images, some showing healthy retinas and others exhibiting various stages of diabetic retinopathy. The dataset should be representative and sufficiently large to ensure the deep learning algorithms can learn from a wide range of examples. Second, pre-processed dataset. Before feeding the dataset into the deep learning algorithms, pre-processing is essential to ensure the data is in a suitable format and quality. Pre-processing may involve tasks such as resizing the images to a standardized resolution, normalizing pixel values to a common scale, and removing any artifacts or noise present in the image. Third, run a ResNet 101 algorithm. With the pre-processed dataset, the first deep learning algorithm, ResNet 101, is executed. ResNet 101 is deep convolutional neural network with 101 layers that excel in image recognition tasks. During the training phase, the algorithm learns to extract features and patterns from the retinal images that are indicative of diabetic retinopathy. Fourth, run DenseNet 121 algorithm. Following the execution of ResNet 101, the second deep learning algorithm, DenseNet 121, is applied to the same pre-processed dataset. DenseNet 121 is known for its ability to capture feature maps efficiently by connecting each layer to every other layer in a dense manner. This architecture can complement the ResNet 101 approach, capturing different sets of features and improving overall detection accuracy. Fifth, comparison graph. To evaluate the performance of two algorithms and compare their results, a comparison graph is generated. The graph typically shows the accuracy of each algorithm in detecting diabetic retinopathy as a function of training epochs or iterations. The graph provides insights into the convergence and effectiveness of both algorithms during the training phase. Sixth, retinopathy detection from test images. After training the ResNet 101 and DenseNet 121 algorithms on the dataset, the models are ready to detect diabetic retinopathy in unseen test images. A set of test images distinct from the training dataset is provided to evaluate the algorithm's generalization performance. The algorithms process each test image and make predictions about the presence and severity of diabetic retinopathy in the retina. So now coming to the execution part, To execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we are containing some of the folders, mild DR, moderate DR and many more. In all these folders we are containing some of the images over there. And now we have a folder named as model. In this we have .h5 files which containing the deep learning algorithms information. These .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks such as making predictions on new data or performing specific operations. And here we have a folder named as test images. In all these folders we are containing some images for testing. Here we have a file retinopathy detection and test train. These two files are the Python files which are containing the Python scripts in it. Here retinopathy detection is the main Python file. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. So now click on upload diabetic retinopathy dataset button to upload dataset for getting the output. Here I am selecting this dataset folder and click on select folder button to load dataset. Here on this screen dataset loaded, and now click on pre-process dataset button to process image for getting the output. Here images processed and displaying one sample loaded process image. Now closing this image, we can see that over here that the dataset contains 11176 as the training dataset and for testing as 2794 over here. And so now click on run ResNet 101 algorithm button to train ResNet 101 for getting the output. So now here we can see ResNet 101 we got 91% accuracy, and we can see other metric output also. And in confusion matrix graph, x-axis contains predicted labels and y-axis contains true labels, and all different color boxes in diagonal represents correct prediction count, and remaining blue color boxes contains incorrect prediction count, which are very few. So ResNet 101 can predict retinopathy 90% accurately. So now closing this graph, click on run DenseNet 121 algorithm button to train DenseNet 121 for getting the output. So here in this graph we got 98% accuracy, and now closing this graph, click on comparison graph button to get the output. So here in this graph, x-axis represents algorithm names, and whereas y-axis represents accuracy and other metric in different color bar, and in both algorithms DenseNet 121 got high performance. So now closing this graph, click on retinopathy detection from test images button to upload folder and getting the output. So now here I am selecting this as cursor 1 and click on select folder button to load images for getting the predicted output. So here in this screen, here we have two images, and we predict over here retinopathy, which you can see in red color, and similarly you can upload other person images and test it. So now closing this both images. Coming back to the conclusion part, while further validation and refinement may be necessary, the successful integration of ResNet 101 and DenseNet 121 in the diabetic retinopathy detection approach signifies a significant step forward in leveraging cutting-edge technology for early disease diagnosis. As advancements in deep learning continue, this approach could become a crucial component of diabetic patient care, contributing to improved quality of life and a reduced risk of blindness for those affected by these debilitating condition. By providing an automated and reliable screening mechanism, the system can assist in the early identification of diabetic retinopathy cases, thus facilitating timely medical intervention and reducing the burden of advanced eye disease on patients and healthcare systems. So here we have completed with our project. Thank you.
For updates on latest project videos, please visit True Projects YouTube channel and subscribe.